We are continuing to talk about solving quadratics. Yesterday we talked about solving by looking at a graph. Today we're going to talk about factoring. So before we get into the lesson itself, we're going to do a little recap on how to factor. We did this on Monday, so this should be a pretty good review. You always want to start by looking to see if you can pick out a GCF. So in example 1, I believe I can pull out a 2 for 2 and a 10, and also an x, since they both have at least one x. That's going to leave me with x plus 5. And that is as simplified as I can go. Because my highest is the squared, and then I have 2x's being multiplied with it. If I have a case, like in number 2, where I don't have a GCF, which I do not, and a is 1, I am simply going to fill in the values that would work. So I know that to get x squared, I am going to multiply x and x, and then put 1 in each. And then I'm going to look at my c term, negative 48, and I'm going to look for numbers that multiply to negative 48 that add to positive 2. And I'm thinking the factors that are coming to mind are positive 8 and negative 6. 8 times negative 6 is negative 48. 8 plus negative 6 is 2. So I'm going to say plus 8, negative 6. Here's my answer. I'm going to follow the same rule for number 3, since there's no GCF and x is, or a is 1. So we know that x times x is going to give me x squared. I'm going to look at factors of negative 24 that add to negative 10. What is coming to mind is negative 12, positive 2. You're certainly welcome to write out all of the factors of negative 24 and then decide at the end which one is the correct one, if it is hard for you to determine that without doing any work. Now for number 4, I do not have a GCF, that's always the first thing I check for, but a is greater than 1, it means I've got to use AC split. So multiply a times c, that's 7 times negative 3, which is negative 21. And b is still negative 4, so I'm going to have negative 7, positive 3. At this point, I'm going to rewrite my original quadratic, except for I'm not going to write the linear term. I'm going to write these terms instead so that I have 4. 7m squared, I'm not going to write the negative 4m, I'm going to write negative 7m plus 3m, and then I'm going to keep that negative 3. This way I have 4 terms. Which is the goal, because I need to factor by grouping at this point. So I'm going to pull out anything that is common in each pairing. So I believe I can pull out a 7m in the first pairing. That'll give me a 1m minus 1. And in my second pairing, I can pull out a 3, and that will also give me m minus 1. Remember, it is important that those 2 terms that you have in parentheses are the same. If they're not the same, somewhere you went wrong. So we're in good shape because we have 2 m minus 1s. I'm going to rewrite that m minus 1. And I'm going to put my leftovers in their own set of parentheses. So here's my answer. We are talking about solving by factoring today, which means our knowledge of factoring should be rather strong. Here's what we're going to do. Yesterday, when we looked at the intercepts, we found that the solutions were where it crossed the x-axis, which meant that our solution was a number times 0. And that means y was 0. So my goal is to get y to be 0. There's something called the zero product property that we can use. And what this says is if the product of 2 things equals 0, at least one of the quantities should be 0. So to figure out what to do, figure out what these values are, I need y to be 0. That was the y value. So 0 equals x plus 4. And then what the product property says is that x plus 4 is either equal to 0 or x minus 6 is equal to 0. So what we're going to do is we're going to take each binomial and separately we're going to set it equal to 0. So we're going to take x plus 4 equals 0 and x minus 6 equals 0. Then we're going to use our good old algebra skills, and we're going to solve for x. So over here, my inverse operation of addition, subtraction, so I'm going to subtract 4. I have an answer of -4. On this side, I need to add 6 to get x by itself. Those are my answers. Maybe in example B, I'm going to take each part and set it equal to 0. So this one, all of the work was done for me. But in my second one, I need to add 8. So my answers, 0 and 8. For example 3, I'm still going to take each binomial, and I'm going to set equal to 0. 2x plus 8 equals 0. 3x minus 1 equals 0. I can solve for x. So my first step, subtract 8. We're in reverse PEMDAS here. So we've got to get rid of things being added or subtracted first before we can get rid of things that were multiplied and divided. So we're getting -4. And 3x equals 1. And can't discriminate against fractions and decimals, they are numbers too. So I also get 1/3. So I have an answer of -4 and 1/3. Both acceptable answers. Same process over here. 5x minus 4 equals 0. 6x plus 2 equals 0. I'm going to start by adding 4. To get x by itself, I'm going to divide by 5. One of my solutions is x equals 4/5. Yeah, x equals -2/6. That can be simplified. If I divide both of those parts by 2, I'm going to get x equals -1/3 as my second answer. So what we're doing is we're taking our factored form and setting each binomial equal to 0 and solving for our variable. I want you to try these yourself. I'm going to give you answers. If you solved correctly, you should have gotten these answers. If you attempted this and did not get these answers, raise your hand so that I can help you. So I would write these steps to success down. You need to first make sure it's in factored form. If it's not in factored form, you have to factor it. You're going to make sure your equation is set equal to 0. Factor out any GCFs, which we're not going to talk about today. We're going to talk about that tomorrow. And then you are going to determine the correct method to solve, and then you're gonna, or to factor method, and you're going to solve using the zero product property. So I have everything equal to 0. That's the first step. Then n squared minus 3n minus 28. I have no GCF in there, and a is 1. So that means I can right away go to my parentheses. I know that n times n is n squared. Then I'm going to look for values that multiply to negative 28, that add to negative 3. I am thinking negative 7 and positive 4. Again, if that's hard for you to do in your head, feel free to just start writing out factors of negative 28 until the correct one comes. So for example, 1 and negative 28, also negative 1, positive 28, 2, negative 14, negative 2, positive 14, etc., all the way down until you find the correct one. It's a little bit more time consuming, but it is also a little bit more foolproof. Now, before in Unit 7, we were done at this point, but since we're solving, I need values for n. So I need to set each binomial equal to 0 and solve for n. So on my left side, I'm going to add 7. I get n equals 7. On my right side, I'm going to add 4. On both sides, of course. N equals 4. We do the same thing in example B. My first step is to check to make sure that right side is equal to 0. Then if I don't have a GCF, which I don't, and a is 1, directly maneuver into my parentheses. I know that k times k is k squared, and I'm going to look for values that multiply to 35, that add to 12. It's going to be a positive 7, positive 5. Then since we're solving, we're going to use our knowledge of the zero product property. We're going to set each binomial equal to 0 and solve. Now in example 3, I do not have GCF and a is greater than 1, then I have to use the AC split method. So I'm going to multiply a times c. It's going to give me 48. And my b, 6. So factors of 48 that add to 26. So it's not 148. 221, there we go. 224. Erase this so I've got space. So I'm going to rewrite this at this point, except for I'm not going to write the linear term. Instead, I'm going to use these to help me. So I'm going to have 3a squared plus 2a plus 24a. These values came from those factors that we found. Plus 16 equals 0. And I'm going to factor by grouping. So on my left side, I cannot pull out any coefficients except for 1. I can pull out an a. So it's going to leave me with 3a plus 2. This is an a, remember. This is a 2. And here it is. And on my right side, I can pull out a 4. That's going to leave me with 3a plus 2. These is either the same. So I'm going to rewrite those. I'm going to write my leftovers in their own. And since we're solving, we're not done. I'm going to apply the zero product property at this point. So I'm going to take 3a plus 2 equal to 0, and a plus 4 equal to 0, a to a. Subtract 2, get 3a is negative 2, and a squared, it's one of my answers. Another answer, -4. If I apply the same idea, for example, B, remember my first step is to make sure that right side is 0 before I can start factoring. I do not have a GCF, and A is greater than 1, so I'm going to factor by AC split. Multiply A times C, it's going to give me 40. And I need to add the 13, terms are 8 and 5. So I'm going to rewrite my quadratic. So I'm not going to write my linear term. Instead, I'm going to write the factors that I came up with as linear terms. So then I have 4 terms, and I can factor by everything. Pull out a 4x, it's going to leave me with x plus 2. And I can pull out a 5, that's also going to leave me with an x plus 2. So I'm going to have plus 2 times 4x plus 5 equal to 0, and then we have to solve, so we have to set each piece equal to 0. Getting -2. And -5/4 is my answer. Okay, I am only going to do a couple of these. I think I'll do 2 of these so that I don't have time to get to the back. I'm going to do A and C. I'm going to come up with the answers, and you're going to do the others on your own. So this is going to be so for example, A, I'm equal to -8 and +2. And for example C, I need to use AC split. This. So Q is going to start to write positive. It does not matter which order you put those 2 linear terms in. You get the same answer at the end if you do it differently. I have to call a minus in this one so that my sign is the same at the end. The answer, you can solve this. Oops. Please try examples B and D as well on your own. Now I want to make a comment about example 4, so we haven't done it yet. You have to make sure that your right side is equal to 0. If it's not, you have to make it equal to 0. So to get rid of this, you subtract 2. I'm going to subtract it only from the like term. So that's going to give me +0 equals 0, which then, that's just this. And then I can factor out the B. I get B is equal to 0 B is equal to negative 1/3. Nice off. I want you to try the last one yourself.